Okay, we asked find the area of the shaded region. Okay, I will use a fast as a formula that whenever you are given this kind of diagram, as long as this is a quarter circle, that's the length here and here are the same, we use this formula that assuming we'll call this area A and we'll call this area B. A is equal to B, yes. I will still prove it. So this area and this area are equal, and both are equal to 4/7. The length here, half of it, that is 4/2 squared. So we have 4/7 times 2 squared. So which is 16/7. So A and B are equal to 16/7, which implies that A plus B, because that's what we are asked to find the area of the shaded region, is now 2 times 16/7, since both are equal, which is 32/7. So the answer is option B. So that's the first one. So let me now prove how I got this formula. That's A and B to be equal to 16/7. Okay, this is similar to the former diagram. So first I will prove that I will start with B, that B is equal to 4/7, half of the length here. So if we call this length, as you can see, these two semicircles and they intersect at this point, it shows that this is the middle. So the middle will be here. That's the center of this semicircle and this. So if we join, okay, maybe call this A, B, C, D. Let's call here E, and let's call here F. So let's join E to D and D to F. We've joined that. So if we call here, let's call this length BE, the radius, which is A. So this is also A, this is also A, this is also A, or you use radius, anyone. As you can see, if we want to get this area, that's area of B, it's the same as subtracting this is 90, this is a straight line. It's the same as subtracting these two quarter circle with the square from the sector, the bigger sector. So if we subtract this area from this sector, that's B. So I'm saying that to get B now is equal to area of sector, that's the bigger sector ABC, minus the sum of the areas of the square, that's EDF A plus sector EBD and sector DFC. So once we subtract this area from the big one, that's B. So an area of a sector is theta, that's 90/3 is a quarter circle, so 1/4 pi A squared. Sorry. 1 over 4 pi 2a all squared. Yes, that's area of this big sector. The radius is 2a. The angle is 90. 90 over 360 is 1 over 4 minus area of a square. You know, this is also a. So which is a square. That's area of this square, and this is a quarter circle. So if you join the two, it's now semicircle. So let's not waste time. So it's now half pi a squared. Do you get this? 1 over 4. 1 over 4 plus 1 over 4 is 1 over 2. So as you can see, this is 4. We have pi a squared minus a squared minus half pi a squared. And pi a squared minus half pi a squared is, okay, let's just continue here, is now half pi a squared minus a squared. And we know pi is 22 over 7. So pi is now half times 22 over 7 a squared minus a squared. This is 11 over 7 a squared minus a squared, which is now equal to 4 over 7 a squared. So have you seen why I said that the area of A and B is 4 over 7? A is half of this length. That's why I divided by 2. So if you compare it with this, you see that A is half of 2a. So we've proved that. Next thing is to prove that this diagram, that's A, is equal to B, but I will use a different diagram. Let me use another diagram. So we have the same diagram, and we're asked to find the area of the shaded region. So if we call the side of the square, let's call it A. So I will join this end, maybe let's name it A B square, A B C D. So let me join B and D. So I've joined, maybe let me use white. Okay, let's call this A1, and here is also A1. These two areas are the same. And for us to get, meaning that the area of this shaded region is 2A1. And if you look at this triangle, we have a sector. You know, this is a square. So each of this interior angle, each interior angle is 90 degrees. So we now have a sector. We have sector CBD, and we're asked to find A1. So it's the same thing as subtracting the area of this triangle from the sector. Yes. So you see that A1 is equal to area of the sector minus area of the right triangle. Yes, as you can see, this is a sector. So if you subtract the area of this triangle from that of the sector, we'll get A1. So an area of a sector is 90 over 360 times pi a squared minus, and you know this is a right angle triangle, so half base times height. That half a times a. So which is now equal to pi a squared over 4 minus a squared over 2. And we can factor what is common in both is a squared over 2. So if we stop factor a squared over 2, we are left is pi over 2 minus 1. Yes. And pi is 22 over 7. So we have a squared over 2. 22 over 7 is now 11 over 7. Do you get? Pi is 22 over 7. So 22 over 7 over 2. 2 and 22 is 11. Minus 1. Which is now equal to a squared over 2 times 11 over 7 minus 1 is 4 over 7. 4 over 7. This is now 2 over 7 a squared. So from this you now see that the area shaded is 2a1, which is 2 times 2 over 7 a squared. So that's how I got 4 over 7 a squared. So that's the formula I use in